Section 13 of The Science History of the Universe, Volume 2. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Avai in January 2016. The Science History of the Universe, Volume 2, edited by Francis Rolt-Wheeler. Geology. Chapter 7, Diastrophism, Part 1. Dynamical geology investigates the process of change at present in progress upon the Earth, whereby modifications are made on the structure and composition of the crust, on the relations between the interior and the surface, as shown by volcanoes, earthquakes, and other terrestrial disturbances, on the distribution of land and sea, on the outlines of the land, on the form and depth of the sea bottom, on marine currents, and on climate. Bringing together the whole range of geological activities, it leads to precise notions regarding their relations to each other and the results which they achieve. In other words, the present order of things must be employed as a key by means of which to decipher the hieroglyphics of the past, and proceed from what may be directly observed to past changes which can only be inferred. We might assume, says Scott in his Introduction to Geology, that the present was so radically different from the far distant past that the one could throw no light upon the other. Such an assumption, however, would be most illogical, for there is nothing to support it. There is no reason to imagine that physical and chemical laws are different now from what they have always been, and the more we study the Earth, the more clearly we perceive that its history is a continuous whole, determined by factors of the same sort as are now continuing to modify it. Some of these forces, however, act with greater efficiency at the present time than they did in the past, others with less. The dynamical agencies may, primarily, be divided into two classes. 1. The subterranean agencies, which act, or at least originate, at considerable depths within the Earth, and 2. The surface or superficial agencies, whose action takes place at or near the surface of the Earth. The former are due to the inherent energy of the Earth, and their seat is primarily subterranean, though their effects are very frequently apparent at the surface. These agencies are also called igneous, from ignis, fire, which is a misnomer, but the term is nevertheless in common use. The surface agents, including the circulation of the winds and waters, the changes of temperature, and the activities of living beings, all depend upon the sun's energy, and were that withdrawn, only such changes as are brought about by the Earth's internal heat could continue in operation. Some of the agencies that shall be considered may seem, at first sight, to be very trivial in their effects, but it must be remembered that they appear so only because of the short time during which they can be observed. For enormously long periods of time they have been steadily at work, and their cumulative effects must not be left out of account in estimating the forces which have made the Earth what it is now. No human eye has ever witnessed the birth of a mountain range, or has seen the beds of solid rock folded and crumpled like so many sheets of paper, or observed the processes by which a rock is changed in all its essential characteristics, metamorphosed, as it is technically called. Yet these things are continually being accomplished in nature's workshop. All such problems, however, must be discussed in connection with structural geology. The logical order of treatment of these subjects is to begin with the subterranean agencies, because the most ancient rocks of the Earth's crust were doubtless formed by these forces, and the circulation of matter upon and through the crust started originally from igneous rocks. These agencies fall naturally into two great groups: diastrophism, or movements of the Earth's crust, and volcanism, or the phenomena of volcanoes, geysers, etc., while a third group, earthquakes, is intimately associated with each of the others, but on account of its great importance will require separate treatment. Crustal movements to be discussed here may be distinguished as 1. Warping, which is a broad, gentle curving of the surface, upward or downward. 2. Direct upheaval or depression, with fracturing and dislocation of the rocks, which may be accompanied by a tilting of the strata. Diastrophic movements of this class are almost, if not quite, invariably associated with earthquakes and can be most conveniently studied in connection with the latter. Permanent changes of level frequently accompany earthquakes, but these are sudden and appear to be nearly always the result of dislocation or faulting. By change of level, in the general sense, is meant the gradual elevation or subsidence of land, with reference to the sea, over considerable areas. Such movements are very slow, and hence are apt to escape observation, so that there is much dispute as to the facts, and still more as to their interpretation. But there is an abundance of indisputable evidence showing that considerable changes in level have been effected even since the dawn of civilization. On certain coasts long inhabited by civilized man, ancient structures like quays and bridges, which were built in the water, may now be found high above it. Such changes have been noted in the Mediterranean lands, especially in southern Italy and the island of Crete. The so-called Serapeum at Pozzuoli near Naples is a famous and much discussed example of repeated oscillations upward and downward. This structure was built in Roman times and probably began to sink while still in use, as appears from the two ancient pavements, one above the other. 3 large monolithic columns of marble, about 40 feet high, are still standing erect, and on each of them is a belt about 10 feet above the ground and 9 feet wide, honeycombed by the boring mollusk Lithodomus, which still abounds in the neighboring bay, and many of the shells were actually found in the columns. Evidently, the building was once submerged to a depth of nearly 20 feet, and when under water the columns were attacked and perforated by the mollusk. Just when the re-elevation began is not definitely known, but it was probably completed in 1538, when a volcanic eruption in the neighborhood resulted in the formation of Monte Nuovo. For nearly a century past a slow movement of subsidence has been going on. Raised beaches filled with the remains of marine animals are a decisive proof of a rise of the land or a fall in the sea, and evidence of a similar kind is given by raised coral reefs. The eastern coast of North America shows marks of relatively late elevation, increasing in amount northward. At the mouth of the Connecticut, the highest beach is 40 to 50 feet above sea level. At Boston, it is 75 to 100 feet. On the coast of Maine, it is 200, and on that of Labrador 500 feet. On the eastern shore of Hudson's Bay the marine terraces and beaches extend up to 700 feet above sea level. In the geological period Pleistocene immediately preceding the recent one, several immense lakes existed in the interior of North America, some around the basins of the present Great Lakes, others in Utah and Nevada. The ancient shorelines of these vanished lakes may still be seen, for the most part in admirable preservation. When first formed by the action of the waters, these beaches must have been level, but accurate surveys show that they are no longer so, but have undergone extensive warpings. As ancient structures on long inhabited coasts sometimes show elevation, they likewise sometimes show depression. On the north coast of Egypt, ancient rock-cut tombs are now visible beneath the waters of the Mediterranean. South of Stockholm, in Sweden, the remains of an ancient hut were found in place, 65 feet below the surface, buried in marine deposits which contain shells of the same species now living in the Baltic. On the west coast of Greenland, the sinking is so rapid as to have attracted the attention of the natives. The sea bottom south of Long Island must once have been dry land, because a river flowing into the sea cannot excavate the sea bottom below the level of its mouth. The ancient channel of the Hudson has been treated by soundings out to the edge of the continental platform, more than 100 miles southeast of Sandy Hook. In the same manner, the channel of the St. Lawrence may be followed out through the Straits of Belle Isle, and that of the Congo extends out 70 miles from the west coast of Africa, with a depth of nearly 1,000 fathoms. What are known as earthquakes are caused by rapid vibrations of the earth's crust due to some sudden shock in the earth's interior. The displacements, that is, the amplitude of the vibrations, in the great majority of earthquakes is only a fraction of a millimeter. When it exceeds 4 or 5 millimeters, the quake is destructive. The greatest destruction is wrought in instances where the buildings are built upon loose foundations or upon made ground. Steel-framed structures founded upon bedrock do not fall easily, for they vibrate with the rock. Centuries ago the Chinese devised an instrument that detected these vibrations of the earth's crust, for the majority of them can only be detected by instruments. Their device, as have all successful subsequent ones, depended on the inertia of a suspended weight or pendulum. The delicately poised weight alone is unaffected by the vibrations. A paper under it moves with the tremblings of the crust, and a pen held by the pendulum records the movement. In the Chinese device, their pendulum merely displaced little bullets which were carefully supported. Modern instruments, called seismographs, do not only tell when an earthquake has occurred, but they record the tremors, different pendulums recording the various components, horizontal and vertical, of the movements. In the cases of a violent disturbance, communication of all kinds is often cut off, but there are now seismographs in all parts of the world, and by comparing the times at which various instruments recorded similar phases of the shock, the center of the disturbance can generally be accurately determined. The study of seismographic records has brought to light many highly significant facts, among others, that minute and insensible tremors of the earth are almost incessant, but some, at least, of these tremors are due to atmospheric changes, and it is not known how large a proportion of them are of subterranean origin. Another very important result of the seismographic observations is that when a very distant earthquake is registered, 3 series of waves are indicated, that is, the first and second phases of the preliminary tremors and the larger waves of the main shock. Those first to arrive, called the preliminary tremors, are believed to be transmitted through the mass of earth along the chord of the arc included between the point of origin and the point of observation. The waves of the third series are longer and slower, that is, of greater amplitude and period, and constitute the main shock. They are believed to follow the curvature of the earth. Sensible earthquakes are numerous, not less than 30,000 being the estimated number per annum. Of course, the great majority of these are very light. It would be just to say that the crust quivers constantly. While any part of the earth's surface may be visited by earthquakes, there is a very great difference between different regions in regard to their seismicity, that is, the frequency and violence of the shocks which affect them. The main seismic regions, when platted upon a map, are found to be arranged in 2 great circle belts, one of which encloses the Pacific Ocean and the other girdles the whole earth. The latter includes the Mediterranean region, the Azores, the bed of the Atlantic westward from the Azores to the West Indies, those islands themselves, Central America, Hawaii, Japan, China, India, Afghanistan, Persia, and Asia Minor. Although earthquakes are commonly perceptible upon the land, the most frequent seats of disturbance are in the bed of the sea. In the sea there are regions quite free from quakes and others of a high degree of seismicity, but quakes also occur in an isolated and scattered manner. Submarine cables are frequently interrupted at the same points. Thus, the cable from the Lipari Islands to Sicily has been broken 5 times at the same point. End of section 13.